Hello students and family members. Tonight for homework we are practicing for our upcoming estimation and number theory test. So let's take a look at some of these questions. Which is the closest estimate? Estimate means rounding. Here are the rounding rules. Step 1, underline. In this case, your highest place value that you share, the tens. Underline, then circle the number to the right. Circle the number to the right. The circled number is the one that you sing the chant about. The underlined number is the one that you change. This is a 4 below, so I leave the 2 go, and anything circled into the right becomes a 0, and you'll be all right. Same thing for the 3, except this is a 5 or above, so I sing the chant about the circled number, and I change the underlined number. 5 above, give the 3 a shove, which would jump that up to a 4. Anything circled into the right becomes a 0. You'll be all right. Circle the appropriate answer. Estimating is rounding. Round to the highest shared place value column, and then estimate for this subtraction. Well, the highest shared place value column would be the thousands, because the 3 in the thousands, even though isn't the highest place value in this number, it's the highest place value in 9,654. So step 1, underline that highest shared place value column. 2, circle the number to the right. Then sing the chant about the circled number, but change or keep the same the underlined number. 4 below, leave that underlined 3 go, like I did here. Anything circled into the right becomes a 0, and you'll be all right. This one's a 5 or above, so I give the underlined number a shove. 9 turns to a 10. And then anything circled into the right becomes a 0, and you'll be all right. Then subtract and find the answer. We have a lot of practice on the back of tonight's homework with questions that look like this. All you are doing is testing the large numbers, 33, 42, 12, 23, 44, 66, 18, and 78, for divisibility. Don't stress yourself out. Pull out a calculator. Remember, checking for divisibility is simply plugging in the large number, dividing it by the smallest number, in this case 3, and if you get an answer without a remainder, then yes, this one is divisible by 3, or 3 is a factor of 33. But this one wants to know which one isn't correct. So you've got to check every single number. 42 divided by 3 is 14, which means these are double yes. So A cannot be my answer because I'm looking for the one that is incorrect. How would I check to see if 4 is a factor of 12 and 23? Well, you got to check by dividing 12 first by the 4, and yes, 12 works. What about 23? 23 divided by 4 gets me a decimal, 5 and 75 hundredths, which means 23 is not divisible by 4, or 4 is not a factor of 23. So this one is the incorrect statement. In fact, I challenge you to check C and D. 11 is a factor of 44 and 66, and 6 is a factor of 18 and 74. How did I know? I checked the larger numbers for divisibility by dividing them by the number I'm checking for factors. You'll do that for all the problems on the back as well. What is the sum of the first two multiples of 9? A big issue in this unit is understanding and knowing your definitions. Well, multiples means multiplication music. I'm skip counting by this number, and they want the first two multiples of 9. So if I know my skip counting by 9 song, I'm just going to put my 9 on the first line, and then the second multiple of 9 is 18. And because they're asking for the sum, you do 9 plus 18 to get the correct response. Flip it over. Question 5. Which pair of these numbers has 10 as a common factor? Well, you've got to check for divisibility to see which one can be multiplied or have 10 as a common factor in the numbers. Here's how you check. We're talking about factors here, so if 10 has to be the common factor, then you should be testing 10 into these other numbers for divisibility. If you understand that a factor is a number that gets multiplied by another factor to get you the product, then you'll realize right away there's only one answer to this question, which would be B. Here's why. If 10 is one of my factors, then I'm multiplying that number by another number to get the product of 20 or the product of 30. So in this case, it has to be 10 times something, which get you the product of 20 or 30. Same thing, 10 times something needs to get me 30 or 20. The only answer it can be then is B. If I move down to 6, we're back into estimation. Ben has 38 bags of pretzels. Each bag has 27 pretzels. Rounding tells me to use the rounding rules or estimate compatible numbers. About, again, tells you to round or estimate how many pretzels does Ben have. You need to take the 38, find the highest shared place value, and 27. So this is a multiplication question. I've got to underline, that's step 1, the highest shared place value. Circle the number or digit to the right, which in 38 is 8 and in 27 is 7. The circled number is what I say the chant about. 5 or above, you give that underlined number a shove, plus 1 to a 4. Anything circled into the right becomes a 0, you'll be all right. You're going to multiply that because this 7 gives this 2 a shove to a 3 because the 7 is 5 or above, which gives the underlined number a shove plus 1, and the 7 is circled so it turns into a 0. Then you've got to make sure that you're multiplying those together and see what is the closest number that you see, A, B, or C. 7 is looking for the actual answer, 567 times 8. You can either throw that in lattice or into a calculator. And the reason they want you to find the actual answer is because then when you estimate this answer, they want to see if it's reasonable or does your answer make sense. I've told the students that if you get a single-digit number, you do not have to round that at all, which means 8 stays 8 because it is only a single-digit number. However, you have to round 567. Circle the number to the right. That's the number you sing about. The underlined number gets shoved or stays the same. This 6 is a 5 or above, so I give the 5 a shove to a 6. Anything circled, which is the 6, and to the right, which would be this 7, turns into a 0. And you'll be all right. And now to get the estimated answer, you're just multiplying, either by lattice or in your calculator, 600 times 8. That will give you two separate answers. The actual answer goes here. The estimated answer goes on this line here. What is the sum of all the factors of 36? Remember that definitions are very important in this unit. Factors, I'm creating a rainbow, which means step 1, start with your product pot of gold number, which is, in this case, 36. I need two factors to get me 36. I start with 1, and the rainbow connects to that number 36. Underneath my factor rainbow, I'm checking out all the numbers that I am testing for divisibility. The next number would be 2. How do I check for divisibility? I take the number 36 in my calculator, I divide it by the number I'm checking or testing, and this time it gets me 18. Which is the number that the rainbow connects to, because my two factors, 2 times 18, get me 36. Now I take 36 and I divide it by 3. That's the next number I check, which gets me 12. So yes, 3 would create another rainbow link, because 3 times 12 would also get me 36. I've tried 2, I've tried 3, they both work. I'm going to try 4. How do I check to see if 4 is a factor? If 36 is divisible by 4, I divide it by 4. Again, that is a factor. 4 times 9 would get me 36. I don't stop there. I've got to test 5. And in this case, when I check for divisibility, 36 divided by 5 is going to get me a decimal, 7 2/10, which means that 5 is not a factor. I'll check 6. 36 divided by 6, and that gets me 6. And on top of that, I've hit my stopping point. Anytime you hit a double, which in this case 6 times 6 is 36, or the commutative property, if you get to 9, you'd realize, well, 9 is already a part of my rainbow, I'm done. You're finished. List your factors. The factors of 36 are 1, 2, 3, 4, I only have to list 6 once. I don't have to write it twice. 6, 9, 12, 18. And yes, that product pot of gold, 36, is also a factor because 1 times 36 does get you 36. They also ask you for the sum. How do you figure out the sum? You need to add all of these together in your calculator. So I would separate these with plus marks, plug it into my calculator, and see what the sum of all of the factors of 36 are. The factor rainbow is the strategy we taught students here. There's many ways to find all the factors of a number, but it's the quickest way to do it that way. Flip it over to question 9. I guess I was joking. This isn't question 9. This is question 1 again. The back 2 pages are more repeated practice on questions that we will see, but also more about vocabulary. The first one is asking about the multiples of 2 and 4. What are the first 2 multiples of 4? Remember that multiples is music, which means I have to skip count by this number. And I'm looking for the first 2 multiples of 4. The first multiple of 4 is always that same exact number, which is 4. And then the second multiple of 4 is 8. Circle the correct answer. Question 2 asks to list the first 3 multiples of 7. Multiples is music. Music means I'm skip counting. The first multiple is 7. 14 is the second multiple. And then the next one I'll leave for you to fill in. The sum of the first 5 multiples of 5. Once again, you're skip counting by that number to list the multiples 5, 10, 15, 20, and 25, but this one asks you to go one step further. It then wants the sum of those first 5 multiples. Sum is the answer to an addition problem. Add them together and fill in your answer here. This one is a totally different question. List all the factors of 18. See how it's almost tricking you. What do you think you're going to do in the workspace? You're right. Product pot of gold. Factors are my rainbows. So 1 and 18, and then you've got a test for the others. 2, 3, 4, 5, 6, 7, 8, and 9. This is what your workspace should look like to list the factors of 18. The first 2 factors are 1 and 18. You create the rest of the rainbow to fill the rest in. What is the sum of the factors of 32? There's 2 things you need to do. We're talking about factors, which means we're talking about a rainbow. Start with 1 and 32. Test for divisibility on other numbers 2 through 9. 2, 3, 4, 5, 6, 7, 8, 9. Right down here. And I'll tell you, yes, 2 is definitely a factor because 32 is even. What does it connect to? How do you check for divisibility? 32 divided by 2 gets me an exact whole number of 16, and I continue. Once you've listed all of the factors right here, I would add them up because you're looking for the sum. Finally, on the back, we just have a couple repeated practice questions with your calculator. Let me show you how to solve. These questions on the back are repeated practice for a question that they will see on the assessment in a couple of days. And once again, you've got to know your vocabulary. 2 being a factor of 24 and 46, you're testing for divisibility of 24 and 46 by dividing each number by 2. So take 24, divide by 2. If you get an exact whole number, which we do, then yes, 24 is divisible by 2, which means 2 is a factor of 24. You do the same thing for 46. Divide that by 2, and once again, you get an exact whole number, which means yes. So if you can answer yes to both of those, that means A is not my answer because I'm looking for the one that is not correct. I continue. How do I check for the divisibility of 12 and 26 by 3? Well, plug the bigger number, 12, by the smallest number, 3. That one will show you, yes, 12 is divisible by 3. However, when I check for 26, and I divide that by 3, I do not get an exact whole number. I get a decimal, which means this one doesn't work, which actually means that in question number 1 here, B is my answer because they want to know which statement is incorrect. I'm still going to test them all. Yes, 20 is divisible by 5. 35 is divisible by 5. 7 is a factor of 28 because when I divide 28 by 7, I get an exact whole number. And 7 is a factor of 42 because when I divide 42 by 7, it's an exact whole number. You're going to test all of these numbers back here for divisibility. Remember, start with the biggest numbers first and divide them by the smallest numbers individually. And if you get an exact whole number like we did for A, C, and D, those can't be right because we're looking for the not correct response. Hope these videos help.